Hello and welcome to another episode of AWS Cloud Bytes. I'm your host Bhavesh Kumar. I hope you are doing great in 2024. Today we are going to talk about Amazon S3 Cloud Storage Service. It's a scalable, secure data storage in the cloud. Let's dive into the details. What is Amazon S3? Amazon S3 or Simple Storage Service is a cloud-based object storage service that offers scalability, data availability, security, and performance. It allows you to store and retrieve any amount of data from anywhere on the web. Let's look into the history of Amazon. It was launched in 2006 as one of the first AWS services. It's an object storage built to store and retrieve any amount of data, which is unlimited, technically unlimited, but it is like horizontally scaled. Provides scalability, availability, security by design, over 200 storage features and capabilities. We may have more today, used by millions of customers worldwide, trillions of objects stored since launch. Since 2006, a lot of people have been using it. It integrates with 100 plus AWS services. What are the key features of Amazon S3? First of all, object storage. It allows you to store files and objects in buckets. We'll talk about buckets in detail in the later slides. Object metadata enables configuration like permissions and encryption. There is no limit on object size. Technically, the limit is up to 5 terabyte. Virtually unlimited storage, which means automatically scales to exabyte of storage. No limits on storage size or number of objects that you want to upload on S3. You can expand seamlessly on demand. Pay as you go. It's not like EC2 EBS volume or a disk that you have to buy upfront. It is like as you incrementally add objects on S3, you start paying for the storage. You start paying for the data transfer based on how you use internally, externally from S3. So pay as you go is only what you use with no minimum fees. There is no upfront cost. Usage is primarily calculated per GB and transactions. The next point is about serverless. It is a fully managed service, so you don't manage any servers. It is all managed by Amazon. It scales and manages infrastructure automatically. It seamlessly scales to manage any volume of data and easily handles any kind of sudden spikes in demand. Durability, it stores data in multiple facilities and servers, so the data is redundant across AZs and regions. It is designed for 11.9 durability, which means your data is literally not going to be lost in any kind of failure of a disk where the data is stored, because there are copies of the same data. Comprehensive security and compliance capability. So you have encryption that you can enable, you have access controls, auditing, compliance certifications. It integrates with VPC for access management. You can control access to your S3 buckets. You can have policies on your S3 buckets and share this resource with external accounts. You have very good capability around auditing, so you can see who has done what. It's a continuation of key features. The next one is around query in-place analytics, which means it allows you to analyze data without having to move it outside of S3. So you have Athena that can use S3 as a data source. You have S3 Select. Good to store static content like images, video files, PDFs, etc. This is more of if you want to do web hosting, you can have it as a static website. All these static assets to a web application can be stored here. The next one is not a file system and cannot be mounted natively to EC2. As I already mentioned, this is an object storage, and it is not like a EBS volume or an EFS network drive. So there is no native support to mount it as a network drive on an EC2. There are some plugins or third-party softwares that will allow you to mimic that, but that's not natively supported. Access objects by key, no indexing. So objects in S3 are accessed using unique keys. It's important to note that S3 is not indexed like a traditional database. Access is based on the specified key, and it emphasizes on the simplicity and efficiency in the data object retrieval. Let's talk about S3 buckets. These are the fundamental containers that store objects. Each S3 bucket is uniquely identified across AWS, so the names of these buckets must be globally unique. Configurable properties like versioning, encryption, lifecycle rules. You have a lot of configurations that you can perform. You have granular configurations for access, security, and lifecycle management. Let's talk about two types of buckets. There are general, which has been there since 2006, and there is a new type of bucket which is called directory buckets. I have a comparison table over here. The structure of a general purpose bucket or the standard buckets are flat. There are no actual directories. While the directory buckets, they are hierarchical. They have folders and subfolders. The object handling is like objects in the standard bucket or the general purpose bucket. And in directory bucket, they are files in directories. The access management is REST API, SDK for general, and then you have network file storage, SMB protocols for directory bucket. The use cases are cloud native apps for general purpose, and directory buckets are primarily to support the legacy app and the file systems. Storage classes, it has all the storage classes except S3 one zone IA. And then you have the second one, which is the directory bucket. It only uses the S3 Express one zone. Performance, it is multi-AZ. It has higher latency. It's a single AZ in directory buckets. It has low millisecond latency. Pricing wise, the general purpose is standard S3 pricing. Directory bucket is a little bit higher in cost than standard bucket. In summary, the general purpose bucket, it stores flat objects optimized for cloud access. The directory buckets provide low latency access to hierarchical directories to support legacy apps. General purpose suits most use cases, while directory suits performance sensitive file-based workloads. Let's look at the bucket structure. What is an object key? So S3 object key represents a file stored in a bucket with folder represented by prefixes. Let me explain you what is a prefix, what is a file. If you look at this particular URL, S3 my bucket /folder1 /folder2 subfolder file.txt. The file.txt is the real file name. We'll talk about each segment of this path. My bucket is your bucket name. This is how the bucket is represented. From S3 to my bucket is the bucket name that is globally unique. Then folder 1, folder 2, and subfolder from here till the file, they're called prefixes. They look like folder structure, but they're just prefixes. So this is first prefix, then folder 2 is a prefix within the folder 1, then subfolder is a prefix within the folder 2. Finally, you have file.txt. File.txt is the name of the object or the file that you have stored in S3. The overall path from folder 1 to file.txt is the object key, which uniquely identifies a file within the bucket. These prefixes that you're looking at, these are like virtual folder structure, and the underlying storage structure is flat, and all the objects are stored at the root level. Let's talk about S3 objects. These are the fundamental entities stored in buckets. Each object is uniquely identified by a key within a bucket. Also, the content of an object within a bucket can be of any data type. You can have a PDF file stored as an object. You can have an Excel stored as an object. You can have a CSV stored as an object. It can be of any type of file up to 5 terabytes. There is no restriction of object types in S3. Metadata like permission encryption can be set on these objects. We can have object metadata such as you can have encryption of AES 256 or KMS keys. You can have an access permission saying this is public, private, authorized users only. You can have storage classes defined, which we'll discuss later in the next few slides. So storage classes can be defined. You can specify the retention settings, replication settings. You can have a lifecycle management applied. Metadata enables you in managing or tagging some objects so that you can manage it at scale. The next point over here is about multi-part uploads. When you're uploading large objects, Amazon recommends that you upload large objects in parts, and where the recommendation is the maximum part size, each part size in the multi-part upload should be max up to 5 GB, and the max object in S3 can be 5 terabytes. The max upload speed in a single put operation is 5500 MBs per second. Higher transfer speeds can be achieved by using multi-part parallel uploads. Last but not the least, both AWS CLI and SDK, they support multi-part uploads. Let's look into S3 storage classes. The first one, which is S3 standard, this is the most commonly used storage class, and this is the default storage class also. As I mentioned, high durability, it's 99.9 nines, total 11 nines across multi-AZs. You have low latency and high throughput performance, and it is suitable for frequently accessed data. And this is also the default storage class. So hosting website is one of the use case. You can have data stored for analytics in this. You can have content distribution, file sharing using this kind of storage class. Let's move to S3 standard. IA means infrequent access. It has a similar durability across multi-AZs. It has data retrieval fees because it is saying it is an infrequent access. So anything that you have and you don't want to frequently access, this will save up some cost in storage if you move the objects that are infrequently accessed. But in case you have to access, there will be a retrieval fee. Lower storage cost than standard, good for infrequently accessed data. It is good for backups, DR copies, or older data. This S3 intelligent tiering, it is basically S3 determining, looking at the application or the user access pattern. It determines whether an object should be in standard or move to some other storage class. So it automatically moves things around between tiers. It monitors access pattern using machine language. There's no retrieval charges or minimums. It is a bit expensive as compared to the standard. It is ideal for data with unpredictable or unknown patterns. It delivers fast access at low latency for frequently used data and automatically moves infrequently accessed data to lower cost. These two were the points that I was not able to fit in properly on the slides. But this is just saying for infrequently accessed data, it moves it to the lower cost. Should have been written in much better way. And for frequently accessed data, it can give you this data in low latency with high throughput. The next one is S3 one zone infrequent access. This is similar to S3 infrequent access, but the only thing is that it is stored in a single AZ rather than multi-AZ. So it is lower cost than other storage classes. Lower availability because it is not in multi-AZ. There is only one AZ, and if that AZ goes down, then the availability may be impacted. It is good for infrequently accessed non-critical data. It saves cost, but the lower availability is one of the cons. The next storage class is about S3 Glacier and Glacier Deep Archive. Glacier itself has at least 3 different storage classes. We are not going to cover a lot about Glacier, but this is like if you want to archive data at the lowest cost with the trade-off of longer retrievals. And if there is a compliance requirement that you have to archive data for, say, 5 to 10 years, you have to have a retention around the data like tax data, financial data, then Glacier is a good storage class. The backup, restoration, or fetching of data will be slower, and depending upon what kind of storage class you choose, because there is a instant retrieval, there is some retrievals that may take 24 to 48 hours. Depending upon your requirement, you'll have to tag it. This is a picture of S3 storage classes. This snap has been taken from Amazon's website. You can see S3 standard, S3 intelligent tiering. There is a new one, S3 Express One Zone. This is for directory buckets. then you have S3 standard IA, then you have one zone IA, Glacier instant retrieval. First byte latency is millisecond for this one. You have S3 flexible retrieval, it has minutes or hours, and then there is a deep archive which takes hours. So depending upon which one you choose, you have different availability, different SLAs, and you have different zones and storage costs and etc. Like some of them will charge you for 90 days, 30 days, 1 hour, and for standard it is not applicable. Let's look into S3 versioning. Versioning allows you to have multiple versions of an object stored in a single bucket, and the version can be enabled at a bucket level. Version ID uniquely identifies each version. I will show you a snapshot of versions. The next point talks about the version retaining whenever there is a new write occur, which means if there is a version 1, then you have some modifications. So version 1 is not impacted. There is a new copy of the object stored. Old versions are not overwritten. New versions are always added. Even if it is a delete, it's a new delete marker. It is not actually deleting the version. Protect against unintended overwrites. It retains the history of change to objects. Why it is useful? It is useful for auditing. It is useful for recovery. In case somebody deleted some of the stuff from your S3 bucket, you can always go and recover by deleting the delete marker. All these objects that were deleted will be available. The bottom line is versioning preserves objects against deletion and overwrites. Helpful for backups and disaster recovery, as I already mentioned. Enable at bucket level for all objects. Adding versioning incurs additional storage cost. You can use lifecycle policies to expire old versions. Suppose you have more than 10 versions of a file, and each version is going to take the same size or whatever the size of that particular version is. As an example, if you have a 5 MB file, 10 versions, which means 50 MBs, will be occupied by all the versions of that particular object in S3. You can set up a lifecycle policy that will say that including the current version, I just want to keep 2 older versions or 3 older versions, and rest can be deleted. Versioning is, as I mentioned, versioning is recommended. Best practice by AWS. It combines with replication for data resiliency. We'll talk about single region and cross-region replication. This is a picture of S3 versioning. I have taken a snapshot of a bucket that I created today. And you can see that I uploaded this JPEG file. And after the upload, I deleted this file. So technically, I deleted the file from the bucket. But because there is a versioning enabled on this bucket, it actually inserted a delete marker over here, which means the file is not visible, but it is still there. And later on, when I upload a new file, you can see that I have this file as a current version, but there is older version of this file, so I can retrieve this version also. And in case I wanted to just retrieve the older file, I could have deleted the delete marker, which will bring this file or show this file in the bucket itself. So that's how versioning works. Let's look into the S3 lifecycle management. Transition objects between storage class based on age. When we talk about lifecycle management, is like how you want to manage an object lifecycle within S3. And given an object is aging within your S3 bucket, it may or may not be important after a couple of months. That particular file or object that you have may or may not be as important as it is today. So after 3 months, you want to lower the cost of storage. You need to have a lifecycle management. So you can transition the object between storage class. You can also set up lifecycle management to expire at the end of the lifecycle. So suppose I can have a document that is available in S3 standard to go to S3 standard infrequent access after 30 days when it is not used frequently. And after 30 days, from there, it will move to Glacier for 7 years. Because there might be a requirement from my compliance or for auditing, I need to have this data for 7 years. After 7 years, I could just say delete this data after 7 years. Similarly, if you have older logs than 365 days, you can just say all the logs available in this particular S3 bucket should be deleted after 365 days. This is a picture of lifecycle management. You can create a lifecycle rule and you have to choose scope. So you can see you can limit this based on some filters, or you want to apply it to the complete bucket, which means all objects in the bucket. Some of the important filters are you can have prefixes. As I mentioned, prefixes, the folder 1, folder 2, subfolder, those kind of prefixes. Or you can add tags to your object, or you can have an object size which is not visible here. There are several ways of applying the filter, which means you are limiting your rule to apply on one of these filters, one or more, or you want to apply it to the whole. This is another screenshot of S3 Lifecycle Management. When you are in your bucket, go to the management. This is one of the lifecycle rule. The status is disable. You can enable or disable lifecycle rule. You remember the scope. Scope can be the entire bucket, or scope can be based on your filter. And this is just saying the current version should be expired. This is like older logs removal. So it just deletes the current version. There is no non-current version, which means there is no versioning enabled on this particular bucket. And there are other filters, other things that you can delete, like multi-part upload. There can be multi-part upload that are not even visible, but they are like incomplete. They will still take your space within S3. And the only way to look at them is using the storage lens, which means you should have a rule that says if there is a multi-part upload and which is an incomplete status for say 7 days, delete those multi-part upload, because if all the parts of a multi-part upload is not uploaded, then the file will not be reconstructed and you will not see the file in S3. So just a tip. Let's talk about the S3 bucket policy. You can have a bucket policy applied. It is very similar to your policies in AWS IAM policies. The structure is similar. You have a JSON-based policy document, and you can have permissions across some or all objects within the bucket. You can have this policy to allow cross-account access to bucket or objects in the buckets. This is an alternative to using ACLs to control access. I have a screenshot around the S3 bucket policies. So if you look at this particular bucket, this is a test bucket that I created today. And the JSON that you see here is defining, saying, deny any kind of put object action that happens on this S3 bucket. And the way we define this whole bucket is by providing the ARN of bucket, which is here. You can see the ARN is here. And with a / and asterisk, which means to all objects within this bucket. The condition is saying if the S3 upload doesn't have the KMS ID, then it will deny, which means encryption has to be enabled on all the objects that are uploaded, else it is not going to allow upload within the S3 bucket. Let's talk about S3 replication. Well, replication is required in cases where you want to have data copied for consumption in other applications, or you want to keep it for DR reasons, or for compliance, or for data management. So this first one is about the same region, copies object between buckets within the same region. So you upload data in bucket A, it will make a copy in bucket B. It is an async replication. These are useful for activities like log aggregation, compliance, working sets. I'll give you some examples around log aggregation. It's like replication log data from several applications into a central S3 bucket. And from there, you can run an aggregation query for analysis. For compliance, replication can help to look into the data compliance requirement. You can replicate objects in separate region for maybe geographic isolation. You can retain the object history and versions for audit trail, and you can lock objects to make replicated objects immutable for, say, 7 years, 5 years, based on whatever your compliance requirement is. If you talk about working sets, so suppose you are having an application that requires this data, and this is like frequently accessed object. You may need this data closure to the compute and the application. You can have these kind of replications which will bring data near to the system that is doing the computation or whatever the application is running to reduce any kind of latency, copying it to the local region. Cross-region replication. Now, the only difference here is it is copying across different buckets in different regions. Region 1 bucket is copying data into region 2 bucket. It is again async replication. It provides you a geographically isolated backup. It protects in cases of regional failures. One of the drawbacks is like you have to pay for data transfer charges because the data moves from one region to another region. I have a screenshot. In the management under the lifecycle rules, you have the replication rules where you can go and create the replication. So you can see there is a rule name, there is a status, there is a destination bucket, and also you have a destination region. If it is a different region, it is like cross region. If it is the same region, it's a same region replication. And then you have the storage class in which you want to do the replication. So suppose you are putting this in standard, but the replicated data is sent to infrequent access. Let's look into additional S3 capabilities. I don't have a lot of information on these slides about them because it will be too big to discuss. So I'm just giving an overview. Object locking, it allows you placing retention locks on object for governance compliance and things like write once, read many use cases. It helps in prevention of accidental deletion or modification of data. Object tagging is basically categorizing each object by custom tag. And as I mentioned earlier, you can have lifecycle policies around tags. So if you tag your objects, you can manage your objects using tags. Event and notification. This is one of the capabilities that I really like about S3 is basically triggering workflows whenever an object has changed or whenever there is a file dropped. You can build a trigger against that. As soon as there is a change in S3 bucket, you can start executing or start consuming that file with whatever process to decipher that file or consume that file further. So these kind of triggers are really helpful in scenarios where you are required to process as soon as the file is available, but you don't want to just keep pinging and looking for new file availability. Access points, custom data access points. There are details around custom data access points, such as you can add a layer of abstraction on top of buckets, and each access point can have its own access policies and settings. These are like access points can be like if you want to share finance read-only access or finance full access. Application can then have access object through these access points, and the underlying bucket stays the same. You don't have to do any customization for these access. Also, it helps customize data access when transforming across accounts. You can configure VPC encryption access permissions per access point, creates levels of access without replicating data. In summary, your access points enable customized access settings, permissions, and endpoints for sharing buckets and objects. This helps customize and scope access without data replication. Let's look at further continuation of additional S3 capabilities. Transfer acceleration. It uses CloudFront edge location for accelerated transfer over long distances. It is helpful for large object transfers across region. Then you have authorization. You have IAM, bucket policies, ACLs, and encryption, which allows you granular access control and encryption. Analytics by using S3 inventory. Then you have S3 Select and Glacier Select. They all allow you to analyze objects. Durability and availability, it's backed by service commitment. So as we already discussed, it is designed for 11 nines of durability and 99.99% availability as a service commitment. Let's look at the key takeaways. S3 provides highly durable, scalable, and secure object storage with robust capabilities. Different storage classes allow optimizing cost based on access patterns. Versioning and replication support data backup, retention, and disaster recovery. Object metadata enables powerful object management capabilities. Integrate seamlessly with many AWS services for analytics, processing, archival, etc. Designed for 11.9% of durability and 99.99% availability. Usage is widespread and growing rapidly, managing trillions of objects. Flexible storage for any use case involving unstructured data. Pay only for what you use with no minimum fees. Secure by default with encryption. Access control, auditing. Innovative feature like S3 Select provides analytics directly on object. To summarize, Amazon S3 is a highly resilient, secure, scalable, and cost-effective cloud storage service with robust capabilities and widespread adoption across many industries. It stores trillions of objects while innovating on new storage features and use cases. Thank you. I hope you liked the video. If you like the video, please like, share, subscribe, and press the notification bell icon for future updates. This is your host, Bhavesh Kumar, signing off. Thank you.